You are at Constanta Dolphinarium. This is the director of the museum speaking, Adrian Bilba. This very new building has been renewed by the Department Council, which has activated the European Fund, and they managed to make this very nice building. We are presenting here not only the dolphins, but also the dolphin lives, also the cetacean lives, because we are a museum and we really want to involve in the edutainment, in the pleasure education. You can see on this diagram, this is the, let's say, the life of the Earth, which was beginning something around 4,700,000,000 years ago. And there was this part without any life. The planet was just getting mature. There was another planet, Theia, which hit, and then after we have the moon. The moon was very close in the beginning, in the former period. The rotation was very fast, was faster than now. The day was not exceeding 6 hours, which means 3 hours of day, 3 hours of night. And then after somehow the life has begun, somewhere around 4 billion years, maybe a bit more, 4,100,000,000 more. When maybe the life has been brought to Terra, to our planet, or has been developed here. Anyway, it was only in the water, developing only in the water, only unicellular life. That was period called Archean, the eon called Archean. And then after, the oxygen has been released in the atmosphere has been mature with containing oxygen, and the life, the biota, has moved to multicellular organisms like soft shell bodies organism, and there was a huge period from 2.5 billion to 0.5 billion, 2 billion years of marine life with soft shell bodies, without any, with almost no traces, no fossils since. But around 450 million years, there was a big change on the biota. They was managing to develop protection, and this protection has been fossilized. And since then we have the Cambrian explosion, and this Cambrian explosion is an important moment because a lot of fossils are coming from that period. But again, the life was developing only in the water. Look how long was the period of the life only in the water. And on the middle of Paleozoic era, eon, first there was the plants, and then after the animals, somewhere around 300 to 400 million years, biota has moved to the soil, to the ground. Also because the oxygen atmosphere has been built enough in order to have the ozone, in order to clean the solar radiation from those which are harmful to life. And there was a big expanding of the life on the soil, on the terrestrial life. We have the Mesozoic period, which is the dinosaurs period. There was it's like a theater in 3 acts, because there was so many animals. They were not producing energy for keeping them warm, so the energy was producing only to develop the body, which makes them possible to be very big and a lot of them. I mean, very crowded. The planet was crowded, and the reason I'm calling this period the theater is this: they was developing a lot of non-verbal language, non-verbal language to use to communicate in between. And after Mesozoic, after the big hit of the meteorite in Yucatan, Mexico, it was 66 million years ago. We have the period of the mammals. Yes, this is a period called Cenozoic, and this is a period where the mammal, which was former time, was only in night shift, let's say, biota, only small individuals, and then after they started to develop big size animals like the animals we have today, the mammals we have today. Now I'm asking you to move on the other chart, which is the cetacean evolution chart, where somewhere around 55 million years ago, there was a boundary between Paleocene and Eocene. There was a thermal maximum, it has been called, and in this period a small animal has moved into the water. Why? Because this temperature was giving the rising of the water. The level of the water has exceeding 100 meters more than previous time, which makes all the continents filled with lakes and water, fresh water in the beginning, and animals has adapted to the water. Either they wanted, either they didn't want it. They have to. Somewhere in India and Pakistan, a small mammal, herbivorous, they started to realize now that this animal was herbivorous, has get into the water. Of course, it is called Indohevus because in the beginning they thought that it's something like a pig, but it is not a pig. It is like a small deer, like 10-kilogram animal, which moves into the water and get adapted into the water. There was a lot of fossils. They have received names. Not all of them has an important moment in cetacean evolution. Some of them, like Ambulocetus, the eyes and the Cucucetus also is not sure that they was contributing to the lineage of cetacean, but they was existing in that period. There was another one, Basilosaurus, which should be from here to here if we would put it on this chart, but also he was not leaving traces in the DNA of the cetacean today. There was a small animal which is something like maximum 2 or 3 meters. Some others say might be 5 meters, called Dorudon. He forgot to, or he didn't have anymore the hind legs, and which makes him look more like a dolphin today, like a cetacean today. He is the ancestor of Odontocetes and Mysticetes. Between them, why I put the Odontocetes before of Mysticetes, because all the Mysticetes in 25 million years ago, there was moving the way of eating from using teeth to using baleen. Well, even today, the Mysticetes, the baleens, even today, they still develop in the embryonic life. They still develop teeth, but they lose after. From the palate, they was managed to grow some filters, and these filters are used to eat small animals from the sea. It was a big moment for the cetacean, something around 25 million years ago, because the water, the planet has been getting cooler, and since then it's cooler and cooler until 10,000 years ago. And this cooling makes big fishes and makes cetaceans, which are homothermous, which are endothermic, to be capable to move to the north and south, to the poles where the water is cold, but is very, very nutritious. I mean, there are many animals, small animals, and these small animals was tempting the Mysticetes to develop this kind of filters. Of course, there are big changes. There are big changes on the respiratory, on the locomotory. They manage to swim. Why they swim like this, not serpentiform like the reptiles? Because there was mammals before. There are mammals, still mammals. There was terrestrial mammals, and these mammals are moving something like dorsoventrally, and the spine is preferring to move in this way. So, yes, they swim like this. About the respiratory system, about the blowhole, some of them still have two blowholes. Some of them have only one, but in the skeletal part, in the cranium, all of them has 2 blowholes, like we have fossa nasalis in any land animals. They don't smell anymore. They don't need to smell anyway. In the water, mostly in saline water, there is no need to smell, and they lost this smell sense. About the vision, because they live into the water when the only or most of the light it is coming on the blue wavelength, so they develop to see mostly in blue, and you can say most of them are monochromatic. I mean, most of the cetaceans see only the blue color or blue shades. But what they develop, it's interesting what they develop a very strange and interesting way of focusing, because they see in the air and in the water, and this is a very big difference in terms of image transmission, and which makes need to focus. Fishes have a focus, but a different kind of focus. We also have a different kind of focus for close view and far away view. But they have a focus when they see in two different kind of medium, in air medium and in the water as well. So it's interesting what was happening with the vision. What is happening with the auditory system? It is even more interesting. They lost the external ear channel. They don't receive the sound the way we do on a land. They don't produce the way we do. We use sounds and we waste air. When we produce sounds, all the terrestrial animals waste air. The cetaceans doesn't waste air when they produce sounds, because they develop a diverticulum, some phonic lips, and they produce sounds without losing air, because the air is coming back into the lungs. This is interesting. But what sound? Because they live into the water, and in the water high frequency sounds, which we call ultrasound, but we call ultrasound because it's our ear, which is limited to 20,000 hertz. They emit, as I said, high frequency sounds, because this sound it is better transmitted into the water, 4 to 5 times faster than the sound, than the normal sound, than the low frequency sound, which makes to have a very fast feedback. So of course the sound goes further into the water, the sound we call sound, or infrasound, and the baleen, the mysticetes still use this infrasound and sound. But when you have to use echolocation, like sending sounds and receiving the echo from a medium which is interesting for you, like for the animals, like the bottom of the sea, like any prey animals and so, or other animals like them, they use this high frequency sound. And this high frequency sound, it is produced in clicks, short waves, short clicks, which makes them have a very straight images, one after another, images from what they are intending to see. So they see in sounds. They see in sounds the way they produce the sounds in the folding lips. They distribute the sounds to the melon. They receive the sounds into the teeth of the mandibular jaw, and then after through the jaw to the bone, to a fat tissue, and then after to tympanic bulla. This is extremely interesting. This is extremely interesting because only the odontocytes, it is known to do this, but in the last research has found that there are some mysticetes which are still using ultrasound and clicking, and so they go in this direction as well, but a bit different. They are not so well known because they haven't been in dolphinariums, haven't been how can I say, checked so much in dolphinariums. But more than that, they are not just clever, they are not just intelligent, they are not just capable of making strategies, they are capable of gestionizing the brain. Their brain, they are better than us in this. They can put asleep part of the brain, because they don't sleep at all on their life, which makes that they are able to command one hemisphere to sleep, the other one to function, in order to keep them awake, in order to keep them floating, because they are not a floating animal. They are animals which are not floating. We float easier than them. They are 50% more dense than we are. So because it's important for them to go deep, not to float. They manage this sleeping issue with deconnecting partially part of the brain. And also they have many other mechanisms which makes the brain to be the last organ suffering from the lack of oxygen. They build oxygen into myoglobin, they arrange the vascular system and they control the vascular system, which is reducing the blood supply when they are immersing to the intestine, to the liver and to the other organs which are consuming oxygen, and they keep this oxygen. They have the deposit in the myoglobin and also in the hemoglobin. They keep it for brain activity, but also the brain activity, they control it the way it's done, only to what it is the purpose. This is a very interesting thing, and the neurologist, the scientist will have to learn more about these animals, because it is also useful for not only neuroscience but also for medicine, neuroscience in medicine.